Okay, so like I said before, we're going over standard and factored forms of quadratics. Quadratics, if you guys recall, are essentially this equation, y equals x squared. And then there's many different variables that can be included into the quadratic so that when we're graphing it, it's at different points along the graph. These are the two forms we're going to focus on today. Standard, okay, which looks like this, our trinomial, okay, because there are three terms here. And we're used to seeing this A being some coefficient, B being some coefficient, and C being a constant. And what we're doing is going from standard to factor form, which is essentially what we were practicing all last chapter. Okay. To go from standard to factor form, what's the process called? Anyone know? Factoring. Makes sense. Okay. Now, the one that's not always remembered as well, what about if we're going from factored to standard form? What's that process called? Yeah, expanding and simplifying, okay? Expanding and simplify. Oh, it's an I, F-Y. I don't know why I kind of write like that. Okay, so expand and simplify. That's exactly what we did the last two chapters. So now what we're going to do is we're actually going to relate these forms. We're going to relate them to graphs of quadratics. Now, you guys should remember from last year, a graph of a quadratic is something called a parabola. And in the first chapter, we actually went over graphing them, where they're facing upwards or facing downwards. And what we were doing is we were looking at it in a form called vertex form, which we're not going to talk about today. Okay, we'll eventually get into that. But we're going to focus on these two and how to graph using these two forms. Okay. Now, standard form doesn't tell us that much information about a graph. It does tell us one thing, which the C is, and we're going to get into it. Factored form helps us out quite a bit. It'll tell us what the x-intercepts are, which are our R and S. Okay. And that information is very important. Once we have x-intercepts, we can find something called an axis of symmetry, and then from there we can find the vertex. Okay, so just to recap, what that means is, if I were to make a makeshift graph here, and let's actually go through all of these here quickly. Say it goes like this. Okay, so here's our makeshift graph. One of these would be considered the R and the other the S. These are our x-axis or our x-intercepts. This is where the graph crosses the x-axis. From those, what we could do is we would add the two together, r plus s divided by 2. Okay? And that gives us something called the axis of symmetry. The axis of symmetry is an imaginary line that runs directly through the middle. I want to use dotted line here. Okay? And then from the axis of symmetry, we can take the axis of symmetry's value and find out what the vertex is. That's all with factored form. Okay? Factored form tells us all this information here. We can figure it all out from there. The standard form, the only thing we can look at the standard form and really figure out is the y-intercept, which is our C. Okay? C will be what our y-intercept is. That's the only thing that standard form really helps us with in terms of graph. Okay. So, with that information, we're actually going to try a question now, and we're going to try to figure all of that out using a simple example from the book. So, the very first example the book gave us, negative x squared plus 30x plus 400. Okay, the first thing I want you guys to recognize is which form is this in? Factor or standard form? Standard. This is in our standard form, okay? And I'm going to actually copy this just so we can... Oh, there we go. Perfect. So you can see the similarities. This is exactly what our standard form is. And what we're going to do is we're going to figure out which is which. What is our A value here? Negative 1. Okay, we can think there's a negative 1 there. And I really should put f at x at the beginning of this. this function in terms of x. What would our b term be? 30, good. And our c term? Okay, good. So looking at this quickly, I'm going to make a makeshift graph on the side, and we'll eventually get into a proper one. But I just want to gather what information I can right now. From standard form, what do I know of this parabola? Y-intercept, what is it? 400, okay? So we know the y-intercept is at 400. That's the only information we have right now. We actually have no idea. Well, we do. We're going to talk about it in a sec. We don't know where or if it has x-intercepts, but we do know this parabola, there we go, goes through 400 somewhere. Now, which way does this parabola open? Downward. Okay, I did forget to mention that. The a value, which we learned about in the first chapter, will tell us whether a parabola opens up or down. There is an a in all three versions. So no matter which version you're looking at, factored or standard, you'll always have an a value. So in this case, it's negative. So we know this is some parabola that maybe goes like this downwards, or maybe it goes like this. We know it crosses the y-intercept at 400 and it's facing downwards. That's the only information we have. So we have to go farther. In order to gather more information, I need to change it to factored form. And to change standard to factored, what process do I use? Factoring. Okay, so we're going to go through factoring. Our term here is a negative. When we have done factoring, we usually work with positive terms. So what we're going to do is find a common factor. And our very first step of factoring is always to find a common factor. We're going to take the common factor of -1 out. Okay? So when we take -1 out, we're going to get f at x is equal to, that -1 comes outside, and now inside the brackets we have positive x squared minus 30x minus 400. Okay? So again, that's our a value. If you guys remember factor form, there's a term on the outside of the brackets. In this case, it's a -1. Now, we're going to go through our longer process of factoring. Remember, we talked about last chapter, we find the factors of the first term. Well, we have x squared, so those are 1x and 1x. Factors of 400 are going to be quite a few. Okay? We're going to list them for now. But as I list them, go in your head and see if you can figure out, remember, this is an a value that's technically 1. We're looking for two numbers that essentially multiply to -400 and add to -30. So as I go through these, you might notice a pair right off the bat. Because both of these are 1, we're really only focusing on the other terms. What is it? Good. Someone already noticed. 40 and 10, instead of going through all of them. Now, this is -400, and that's -30. So which of those terms needs to be negative? -40. 40 needs to be negative, because remember, we're going to be adding them together. Okay? If you don't remember factoring, you've got to go back and look that over, because you have to know it for this chapter. So if you struggle on that, go watch another video on factoring or practice some of the questions. So what that means is we now know our factoring, or our factors. So our terms are -1. And because the first terms are the same, it doesn't matter which bracket we essentially put them in. One of the brackets will read -40. The other one will read x plus 10. So this is our factor form, if you recall, all the way up here. And we're going to draw a similarity to it again. Copy this. Bring it downwards. If you notice, again, this is very similar to our factored form. F at x is equal to. Now in this case, our a term, if you notice, our a term in standard form and factored form is the exact same. In all three forms, it will be the exact same. That's essentially the only variable in the forms that stays consistent. Our r in this case, or s, it doesn't actually matter which order you put them in, is 40. And in this one, our s is 10. Okay? Now, technically, in order to figure out x-intercepts, we're going to focus on the equation we have in factored form here, okay? This equation here. Technically, when I'm on my x-axis, which is up here, what is the y value on the x-axis? 0. So y is equal to 0 here. Well, in our function, which of these terms or symbols represents the y? Which represents a y value in here, okay? -1 is an a. What does this represent? What letters literally is that saying? X, okay, so we know that's not y. What other variable do we have that could replace y? F at x, okay? Remember our function notation, we can essentially interchange f at x and y when graphing. We talked about that, so you have to go back and look. So, essentially this equation can be rewritten as y is equal to negative 1, x minus 40, x plus 10. Now, like we said, the y value on our x-axis is 0. So what we're going to do is we're going to replace y with the term 0. That way we find our x-intercepts, and that's what we were talking about RNS. So if this is 0 is equal to negative 1, x minus 40, x plus 10. Okay. I need to isolate these for x. Well, I have a negative 1. How can I get rid of this negative 1 since it's multiplied by? How can I eliminate it? If it's negative 1 times this term, how do I move it to the other side? What's opposite of multiplication? Division. We can divide by this, okay? So many of your teachers in the past would have just dropped this off. I want to show you that you would divide by negative 1 and you divide by negative 1. Well, negative 1 divided by negative 1 creates a 1, or what we call usually canceling out. What's 0 divided by negative 1? 0. That doesn't change, okay? So now all we have is x minus 40. We're going to bring this to the forefront because this part's very important for understanding what we're doing here. Okay? We now have x minus 40 times x plus 10 is 0. Let's think about this. This is multiplication between the two. And we know when we multiply, think of this as a term and another term. When we multiply these two terms, we get 0. What is the only term you can multiply by to get a 0? 0. That's the only term we can multiply by. So in other words, one of these must equate to 0. Okay? We don't know which one. So what we're going to do is we're going to test for both. If both of them were 0 or if either or were 0. Okay? So this is what we do is we split the equation. The equation now becomes 0 is equal to x minus 40. Okay? That would be this first set here. We're figuring out if that guy was 0. And if this guy was 0, well, 0 would be equal to x plus 10. So we find the two instances when when the y value will be 0. In this case, we're going to get x is equal to, we bring 40 over, it becomes positive 40. And in this case, we get x, we bring it over, it becomes negative 10. So let's draw a similarity again. 40, negative 10. Remember we talked about these terms being our RNS? Well, this is negative 40, and this is positive 10. So the RNS values, when we're factored, if there's only a 1 term here, are essentially opposite. Now, if there wasn't a 1 term, like this was a 2 or a 3, we'd have to do this process to find out exactly what the terms are. But what we just discovered are our x intercepts. Okay? So let's go back up to this question. Our x-intercepts are positive 40 and negative 10. Okay, so I have positive 40, we'll do it in blue. This is an x-intercept, and another one is negative 10. Okay, so in all likelihood, we probably have some graph that looks roughly like this, where the vertex comes after and then comes down. We know the vertex was going downwards, it crossed the y-intercept at 400, and it crossed the x-axis at negative 10 and 40. I could still find the vertex with this information. These two terms here will help me find the vertex. The vertex is going to be directly in between the two of them. So remember we said our axis of symmetry, which I'll call AOS, are r plus s divided by 2. Essentially, it's just finding the middle of these two terms. So we're going to go 40 plus negative 10 divided by 2. Well, what's 40 plus negative 10 divided by 2? 15. So the axis of symmetry, we'll go back up to our graph, we'll draw it. Thank you. It's okay. Axis of symmetry is at 15. We'll say it's roughly there. So what that means is there is an imaginary line going right through the middle of this parabola at 15. Okay? And we know the vertex is definitely going to be on here. We just don't know what the y value of the vertex is going to be. So this is our very last step. We take this axis of symmetry, 15, and we plug it into either the standard form of this equation or the factored form of this equation. But either equation will give us our y value. Okay, so I know there are many, many steps to this. So let's take, I'm going to take the factored one because I think I remember that best. The factored of this equation, f at x was equal to -1 x minus 40 x plus 10. I'm going to take this axis of symmetry, which, like I said, is the x value of the vertex, and we're going to use it to find the y value. So I'm going to replace both x's in here with the value of 15. So when f at 15, essentially what's our y value? We'll get -1. 15 minus 40 in brackets. We always do brackets first. 15 plus 10. This is going to give us -1 times 15 minus 40. 15 plus 10. Positive 25. Just want you to notice that those absolute values of those terms are the same, which gives us an idea that it is directly in between those two x values. Okay? And -1 times -25. Positive 25. Positive 25 times positive 25. I need somebody to help here. What is it? 625. Beautiful. So, 625. This is our vertex. I hope you're right. I didn't really check. It is great. So what that means is our vertex is at all the way up here. We can now draw this parabola, so I'm going to connect the dots. Vertex ends there, comes back down, and the y value of the vertex is at 625. Okay? So, with standard and factored form, we can find out all that information about our graph. Okay? We just have to go through the steps, which are factoring it. This is where we factored it, put in factored form. We find the two x-intercepts from factored form. We find the axis of symmetry. Then we take that value, plug it back in to find the vertex. A lot of steps to this.